Welcome. So in this video, I want to talk a little bit about an introduction to number systems in general. We'll talk about integer-based number systems. And then in later videos, we'll talk about binary and hexadecimal specifically. Okay, so the first thing you need to know is you know everything you need to know already about number systems. Okay. If you know decimal base 10 number system, basically, if you can count from 0 to 100, you know everything you need to know about any integer-based number system. So let's start with my number system rules. These aren't Rick's number system rules. These are just my generalization of integer-based number systems. Okay, so no matter what number system we are talking about, base 10, base 2, base 16, the first digit is always a 0. Okay, so whatever base we are talking about, base n number system will have that number of digits. For example, decimal is a base 10 number system, so we'll have 10 digits starting with 0. Okay. Base 2 number system will have 2 digits, again, starting with 0. And that's how many digits it's going to have, 2. We saw 10, we'll have 10 digits, 0 through 9. Hexadecimal number system, 16 digits, base 16. Again, starting with 0, 16 digits. And we'll talk more about that a little later. Okay, now if we look at the first column, the rightmost column, whatever you want to call it, in whatever base we're talking about, the first column is always the column of ones, the number of ones. We'll see this more in a moment. Every column after that is, well, in base 10 would be 10 times the previous column. In base 2 would be 2 times the previous column. Base 16 would be 16 times the previous column. We'll see more of that in a moment. But here's another example. Base 10, base 2, base 16. All three number systems here, first digit begins with 0. Base 10 has 10 digits, 0 through 9. Base 2 has 2 digits, 0 and 1. Base 16 has 16 digits. First 10 digits, it uses the same as our decimal number system, 0 through 9, and then a sequence of symbols that we're all familiar with the sequence, and that's the alphabet, A, B, C, D, E, F. Okay, so all three number systems, the first column, the rightmost column, is the column of ones. In base 10, the next column would be 10 times that, or 10. And every column after that would be 10 times the previous column. Base 2, the next column is 2 times this column. Every column after that would be, well, we're talking base 2, 2 times the previous column. This will all make sense here when we look at each of these number systems, binary and hexadecimal, individually. Now, base 16, well, column of ones, base 16, the next column would be 16 times that column, or the number of 16s. Next column after that would be 16 times that, 16 times that. Okay, so base 10 number system. If you know base 10 number system, like I said previously, excuse me, then you know everything you need to know about it, any other number system. In the base 10 number system, we have 10 digits starting with 0, 0 through 9. The rightmost column is the column of ones. The next column after that is 10 times that, then 10 times that, etc. Now, in each one of these columns, we can put any of these numbers, and only these numbers. Okay, so I can put a 7 here, a 0 here, and a 9 here. These are also known as positional-based number systems, meaning the position of the number matters. Okay, putting a 7 here followed by 2 more digits means that this 7 isn't 7 ones. It's been moved over here to the 100s column, so it's 7 100s. A 0 here means 0 tens. A 9 here means 9 ones. Okay, in base 10, okay, we have those 10 digits. If I was counting in binary, in base 10 decimal, and I got all the way to 8, okay, sounds good. What if I increase this by 1? What's my next value? My next value is a 9. All right, what do I do if I want to increase this by 1? I've run out of digits here. Now, this rule, you already know the rule. Okay, maybe you don't think of it like this, but you already know what to do. And if you know what to do in decimal base 10, you know what to do in base 2 or base 16. Just follow the rule. So we've run out of digits here. What do? We go all the way over here, put a 0 in this column, and increase the next column by 1. Although there's nothing here previously, you can think of it as a 0. Leading zeros with no other number doesn't change the value of this number. So in having nothing here or a 0 is the same number, 0, 8, or just an 8. Okay, so what did we do? We had 9 ones. Now we have 0 ones, but we have 1 in the tens column. Okay, if I kept on adding 10, 11, 12, 13, and I got to 18, okay, then we add 1 to 18. I go from 8 to a 9 in this column, okay? Now, what if I want to add 1 to 119? I want to increase this by 1. Okay, again, I'm at the 9. So in this column here, I'm going to go from 9 to a 0. 9 to a 0. Increase the next column by 1. So I went from 1 to a 2. Okay, I know you already know this. And if you understand this, then you understand everything you need to know about binary and hexadecimal. Okay, so I talked about that our integer-based number systems are positional. I have an 8 here. Okay, this would be the same thing as if I had an 8 here with leading zeros. Doesn't matter how many leading zeros I have. As long as it's just a bunch of zeros, it's the same value. However, if I put an 8 here and have the zeros following the 8, then it moves this 8 over 2 columns to 8 100ths. Okay, so having 008 is not equivalent to having 800. So yes, following zeros make a difference. Okay, and that's something that we have to be sure of when we do other number systems. Don't forget, if there's supposed to be zeros following whatever value we have here, don't forget those following zeros. Okay, so in the next set of videos, I'm going to talk about binary and hexadecimal using these same rules we talked about here.